In this lecture, we are going to discuss about Euclidean algorithm. Euclidean algorithm is used to find the GCD of two numbers. First, we will see the algorithm, then we will solve problems based on the algorithm. Let A is greater than or equal to B greater than 0. By division algorithm, when A is divided by B, then you get quotient and remainder. So, A can be written as BQ plus R. So, like that, here when A is divided by B, then you get quotient and remainder. So A equal to Q1B plus R1, where 0 less than R1 less than B. Similarly, when B is divided by R1, then you get B equal to Q2 R1 plus R2, when 0 less than R2 less than R1. Similarly, when R1 is divided by R2, then you get R1 equal to Q3 R2 plus R3, where 0 less than R3 less than R2. If we keep on going, then at one stage Rn minus 2 equal to Qn Rn minus 1 plus Rn, where 0 less than Rn less than Rn minus 1. In this next step, Rn minus 1 equal to, when Rn minus 1 is divided by Rn, then Rn minus 1 equal to Qn plus 1 plus Rn, not plus, into Rn plus 0. Hence, here the remainder is 0. If you get 0 as a remainder, then Rn, the last non-zero remainder, Rn is GCD of A comma B. This is the Euclidean algorithm. And one of the properties is that the GCD can be written as Rn equal to GCD of A comma B as a linear combination of the given numbers, that is Ax plus By. Now we will solve the problem based on Euclidean algorithm. So the problem is find the GCD, find the GCD of 1, 2, 3, 7, 8, comma 3054. Find the GCD of these two numbers and express the GCD of the same numbers as a linear combination of the same numbers 1, 2, 3, 7, 8 and 3054. So for that, first you divide the greater number by the smaller number. So here greater number is 1, 2, 3, 7, 8. Now divide this by 3054. Then you get quotient as 4. Now if you multiply 3054 into 4, then you get 12216. Now the remainder is 162. Now again you divide 303054 by 162. Then you get remainder, quotient is 18. Now multiply 162 into 18, then you get 2916. Then you get remainder is 138. First you write this one. So 4 can be written, 12378 can be written as 4 times 3054, and then plus remainder is 162 by division algorithm. Now once again you divide 3054 by 162, then you get 18 is the quotient and 138 is the remainder. So 3054 can be written as 18 times 162 plus 138. Now once again you divide 162 by 138, then you get 1 is the quotient, so 138, so remainder is 24. So 162 can be written as 1 time 138 plus 24. Similarly, now divide 138 by 24. 138 by 24, then you get 5 is the quotient. If you multiply 5 and 24, then 120, then remainder is 18. So 138 can be written as 24 times, no, 5 times 24 plus 18. Similarly, now divide 24 by 18. 24 by 18, then what you may get? 1 is the quotient, 18, then remainder is 6. So 24 can be written as 1 time 18 plus 6. Finally, 18 can be written as 18 divided by 6 is 3. So 3 times 6 plus 0 is the remainder. So the last non-zero remainder is 6 in this algorithm. So 6 is the GCD. Therefore, GCD of 12378 and 3054 is 6. The question is find the GCD. So first part is over. Next part is express the GCD as a linear combination of the given two numbers. So for that, you start with now start with this equation. So here 6 can be written as 6 equal to the GCD equal to 6 equal to 24 times, what is it, 24 times 24 minus 1 time 18. So write this equation. So 6 equal to 24 minus 1 time 18. Similarly, in this equation, 18 equal to 138 minus 5 times 24. So here replace 18 by this. Okay. Then what you may get? 24 minus 1 time. So 18 can be written as 138 minus 5 times 24. So now simplify this as follows. Then what you may get is 24 minus 1 time 138 minus minus or minus plus 1 time 5. So 5 times 24. Now the previous equation is what? So this can be rewritten as 24 equal to 162 minus 1 time 138. So now substitute for 24. Okay, then what you may get? Before that you simplify it. So here this is 1 time 24, this is 5 time 24. So totally 6 time 24 minus 1 time 138. Now 24 can be written as 62 minus 1 time 138. So substitute that one. So which is equal to 6 times 24 minus, no, we are substituting for 24, right? So 162 minus 1 times 138. 162 minus 1 time 138 minus here 1 time 138. So totally what is it? What you are having? 162, right? Yeah, 162. So what you may get is 6 time 162, and here minus 6 times 138, here minus 1 time 138, so totally minus 7 times 138. Now in the previous equation, here 138 can be written as 3054 minus 18 times 162. Now substitute this for 138, so which is equal to 6 times 162 minus 7 times. So for 138 we can write as 3054 minus 18 times 162. Now simplify, then what do you get? Here 6 times 162, here 18 times 7. So 18 times 7, 126, already 16. So 132 times 162 minus 7 times 3054. Finally, the previous equation is what? 162 can be written as 12378 minus 4 times 3054. Now substitute this thing in this equation, then what do you get? 132 times, okay, 12378 minus 4 times 3054. Now simplify, minus this 7 times 3054. Now simplify these two. Before that, 132 times 12378, and then 132 times 4, and then minus 7. What is it? 132 times 4. So 2 4s are 8, 3 4s are 12, 1 4, 528. 528 plus 7. Okay, 535. So minus 535 times 3054. So this is the required solution. That is GCD of 12378 comma 3054 is nothing but 6, which can be written as a linear combination of the given two numbers. Thank you.